Welcome to CAB Builder online training series. This video will tackle the construction global options by setting up connections and a drawer box construction. Construction methods answer the question of how are cabinets built. The answer encompasses overlay reveal settings, grain directions, facade orientations, drawer box dimensions, connection tolerances, and other manufacturing standards that differ from cabinet shop to cabinet shop. This is a very impactful piece of the software that influences many cabinet calculations, so it is highly encouraged that new CAB Builder users configure their construction methods before tackling other aspects of their cabinet catalogs. Navigate to the construction module. Take a look at the main control panel, and you may notice this menu is split between three sub-modules: construction cabinet, construction drawer box, and construction connection. We will start with the simplest of these, which is the drawer box construction. The left column of this menu has the available drawer box construction. These make up the possible selections for the corresponding global option. Selecting a method will show its construction options in the middle column. Clicking on one of these options shows its parameters and assignment in the right-hand column. You have a default template for your starting point. This template is marked with a lock label, meaning it cannot be changed. Create a drawer box construction method by clicking Create at the bottom left of the screen. The first category of drawer box options is dimensions. This is where the user tells CAB Builder what set of depths and heights are available for the boxes, as well as the minimum clearances between the drawer box and its opening. These will set the formula for drawer box widths, heights, and depths for a given space. Select the drawer box height parameter. If we look over to the right, you will see that CAB Builder gives three options for this setting. One is fit to front section, 2 is unified depths, and 3 is increment. Fit to front sections will assign the maximum value to the drawer box heights after the appropriate clearances are accounted for. Here is an example. CAB Builder sees a drawer opening of 6 inches between the top and mid boundaries, with a bottom clearance of ½ inch and a top clearance of 1 inch. That leaves a possible maximum height of 4½ inches. Fit to front will use this maximum for the drawer box it creates. Unified heights, on the other hand, restricts the program to a discrete set of height values. Suppose this unified heights is enabled with a list of 2, 2½, 3.2, and 3.6 inches. Going to the previous example of a maximum of 4½ inches, CAB Builder will choose the biggest value from the available set of heights. This is 3½ inches in the current implementation. Increment will also create a discrete set of available heights, but with a different approach. The user must first specify a starting point, an increment, and an endpoint. CAB Builder takes these values, starts the set with the starting value, then adds new heights by adding multiples of the increment. For example, if the starting point is 2, increment is 0.5, and endpoint is 5, then the available list of heights will be 2, 2½, 3, 3½, and so on until it reaches the maximum of 5 inches. So let us revisit the previous example, except now with a start of 2 inches, increment by 3/8 of an inch, and a maximum of 10 inches. The resulting drawer box height is 4¼ because that is the maximum that could fit under the 4½ inch limit. Calibrate your drawer box depths in the same way, either fit to front, unified, or incremental depths. Configure the clearance values next. These will take effect if they are greater in value than the corresponding drawer guide parameters. The next section of drawer options is the construction of every piece of the box, starting with the side. The first parameter is default part thickness. Every piece will have this parameter, and it describes the thickness CAB Builder expects for the part. The actual thickness that will be used for the piece is determined by the properties of the material assigned, so this will serve as a check between construction methods and material assignment nominal thicknesses. The side height adjustment is an option specific to the side of a drawer box, while the next option is once again shared by every construction method. This banding attribute determines which sides will be edge banded. Activate the corresponding checkboxes to apply the banding. Calibrate the settings for the construction drawer box back, front, and bottom constructions, each with their common and unique properties. The final section is called joints. This is where the user instructs CAB Builder how all the drawer box parts must be connected. Each connection can have unique joints, so this list will have every permutation of connections that can be had within the drawer. But how can we tell CAB Builder what type of connection we would like to apply? How does the software know the tolerances, clearances, tenon dimensions, notch depths, etc. This is the purpose of the third submodule called Construction Connection. This menu has the same layout as the former. You are provided read-only templates of every joint type, each with its own unique set of parameters. Click Create at the bottom left of the screen. Use the drop-down menu and select the dado template. Name this new joint and click Create. Now select the newly created joint and look at its options in the middle of the screen. The first option, dado type, controls what cut the dado notch will have. Following this are more dado parameters, such as dimensions and adjustments. A common joint used between drawer box front side and back side connections is the dovetail joint. So repeat the joint creation process, except now with a dovetail joint template selected in the drop-down list. This type of joint will have its own unique parameters that must be set by the user. When the dovetails and dados are ready to go, we can go back to the drawer box construction and assign them where appropriate. Expand the joint options and select the side to bottom connection. The first setting you will see in its attributes will be which part extends to the other. This determines which piece will act the male and which the female. The extended part is female, meaning joint parts like notches will be drilled onto that piece. The other part will have the corresponding connection, such as tenon in the example of a dado. Alternatively, you may choose to miter the connection. Select Extend Side to Bottom to assign the notch to the side. What remains is for the user to tell CAD Builder what joint to use. Enter the connection selection menu by clicking on the three dots under Parts Connection. This menu is also split into three columns. The leftmost column shows the categories of connections that can be applied to this joint. Clicking on one of these will reveal its connections in the middle column. Connection parameters are shown in the rightmost area in read-only mode for verification. Click on Dado Connection. Select the dado joint you have created and verify its parameters in the right-hand column. If everything checks out, click Select at the bottom of the menu to assign the joint. The result is that every time this drawer box construction is used in the design, all the side to bottom connections will be calculated by the joint you have created. Repeat the same assignment for the bottom to front and bottom to back joints, and then assign your custom dovetail joint to the other two connections. Congratulations! You have now completed a drawer box construction method for your catalog. The next video will cover the twin menu called Cabinet Construction. Thank you for watching, and I will see you then.